Hey guys, today we are looking at two different I can statements. The first I can statement that we're looking at today is I can graph linear functions in standard form and identify and locate intercepts. Today we're looking at this word problem about Janine. Janine is shopping for t-shirts and sweatshirts. She plans to spend $100. If all $100 is to be spent, an equation can be written using X to represent the number of t-shirts and Y to represent the number of sweatshirts. So we need to write this equation. And t-shirts in the picture says is $10 each, and sweatshirts is $20 each. So the equation, if X represents t-shirts and Y represents sweatshirts, we're going to take and multiply the price of the t-shirt times the number of t-shirts that there are. So we don't know how many that is, so that's X. And then we're going to add that to the price of the sweatshirts, which is 20 times Y, and we're going to set that equal to 100. That's the equation. Now, what type of numbers can X and Y be? X and Y can be any whole numbers only. The reason it can only be whole numbers is because it's real items. It cannot be fractions or decimals, and it cannot be any negative numbers. That's what a real number is. And any non-negative real numbers, it can't be fractions or decimals because it's t-shirts and sweatshirts, and that's why it's whole numbers only. Next, we're going to use the graph to find all the solutions to the situation. If you look at this graph, it's got ordered pairs on it. This ordered pair represents 0, 5, and 0 represents the number of t-shirts, and 5 represents the number of sweatshirts. So 0, 5 is 0 t-shirts, 5 sweatshirts. 2, 4 is 2 t-shirts, 4 sweatshirts. 4, 3 is 4 t-shirts, 3 sweatshirts. 6, 2 is 6 t-shirts, 2 sweatshirts. 8, 1 is 8 t-shirts, 1 sweatshirt. And 10, 0 is 10 t-shirts and 0 sweatshirts. That's what the graph represents. Now, how do the solutions to this situation stated above relate to the linear equation that represents the situation? The solutions make the equation true. It is only combination of t-shirts and sweatshirts that she can purchase under or for $100. What is being each intercept in the context of the problem? It is the maximum number of t-shirts and sweatshirts. she can purchase. All right. The next I can statement that we are going to look at is I can determine the slope of a linear function given a graph, an equation, and 2 points. Slope is called the rate of change when the variables have meaning and or units attached to them. Consider a car traveling at a constant speed. So this car is traveling 45 miles and there's 12 gallons of gas left in the car. Now the car has driven 255 miles and there's only 5 gallons of gas left in the car. So they have created a graph for us. The graph shows the relationship between the gasoline left in the tank and the distance traveled. So determine the rise between the 2 points. So the rise, remember, when we're determining the rise, it's how much of the vertical distance it is. So we're going to do 5 minus 12, and that gives us -7. And what does the rise represent? It represents the amount of gasoline used. Determine the run between the 2 points. In between the 2 points would be 255 minus 45, and that's 210. And what does that represent? It represents the distance traveled. Now, find the slope. Well, we've got the rise and we've got the run. So all you have to do is write it as a fraction, -7 over 210. Now we need to reduce that. So if we grab Desmos, if you grab Desmos and you type -7 divided by 210, it gives a decimal, and you don't want a decimal for slope, so you're going to click this button right here on the side, and it changes it over to a -1/30. So my slope is -1/30. And what does the slope represent? For every 1 mile, I'm sorry, for every 1 gallon of gas used, you can go 30 miles. All right, we're going to skip letter D for time's sake and move on to Allison. Now, Allison walks 4 miles by 9 a.m. and she walks 8 miles by 11 a.m. Write the information as an ordered pair, graph the ordered pairs. So the time is 9 and the miles was 4. That's the first ordered pair. The second ordered pair, she walks 8 miles by 11 a.m. So 11 a.m. and 8 miles. So now we're going to graph that over here. 9 is my X and 4 is my Y. So 9, 4, And then 11.8 is just off the graph a little bit. That's why it's not good to graph these things, because not all the time is your graph going to be accurate, because it's not always going to be big enough. So we graphed it. Find the slope using the method of your choice and describe its meaning in the context of the problem. So we're going to find the slope using the formula x1, y1, x2, y2. Remember, the formula is y2 minus y1 over x2 minus x1. Now, y2 was 8 minus y1 is 4 over x2 is 11 and x1 is 9. So 8 minus 4 is 4. 11 minus 9 is 2. 4 divided by 2 is 2. So the difference in miles was 4. The difference in time was 2. And that reduced down to 2. You can use the formula, or you can make a table. If you wanted to make a table, this is what that would have looked like. 9, 4, 11, 8. Going from 4 to 8 is adding 4. Going from 9 to 11 is adding 2, which gives you the same thing, 4 over 2, which gives you 2. So either way that you wanted to do it is totally fine by me. Just show me your work, whichever way you wanted to do it. Now, describe the meaning in the context of the problem. She's going 2 miles for every hour. 2 miles for every hour. If Allison continues to walk at this rate, how far will she walk by 12 o'clock noon? Well, we know at 11 o'clock, she has walked 8 miles. And if she's going to walk at 12 o'clock, that's only 1 hour later. And if she's walking 2 miles for every hour, what is 8 plus 2? That's 10. So she will have walked 10 miles at noon. So remember, the distance that you travel changes with the amount of time you travel. You can describe the change in distance compared with the change in time with slope. So that's just one way of doing it. Now you guys are going to take your homework quiz. So I wish you luck on that, and have a great weekend.